in this video, I wanted to give you a little bit of background, maybe motivation for these properties of logarithms. So I'm going to show you the proof of each property, and then we're also going to talk about the change of base property as well. You don't have to know the proofs in order to be able to use these properties and to do the topics that are assigned and be successful in the class. But sometimes I think it's helpful to know like how these kind of work. Okay, so let's start with this product property. And for all of these, we're going to do something maybe a little annoying. We're going to introduce some more letters because we don't have enough letters here. But to make it a little bit easier to write things down, let's let m be the log base b of x. And normally I would say n, but that gets a little confusing. Let's see, what's another good letter? How about k? Yeah, let's let k be the log base b of y. Okay, and so then going back to that's an x, going back to the definition of a logarithm, we could rearrange each of these. And so for m equals log base b of x, we could write that this means that x is equal to b to the m. So that's just using the definition of a logarithm and writing it in exponential form. And then same thing over here, we could write that y is equal to b to the k. Okay, so let's look at this product property. So let's see what happens if we kind of look inside these logarithms here and actually look at this x times y. So this for the product property, let's look at what x times y is, since that seems to be an important thing with this property. So x times y. Well, since we have kind of introduced this m and this k and rearranged things, we're saying that x, we can write it as b to the m, and then y is b to the k, so times b to the k. And we know from working with exponents in previous classes that when you have the same base, you add the exponents. So this is equal to b to the m plus k. Okay, let me do this. Let me rewrite this and kind of leave out this middleman. So x times y equals b to the m plus k. So we now have this little equation here, and it's written in exponential form. How about we rearrange it and get it back into log form? So the base of the exponent b becomes the base of the logarithm. So the base of the logarithm is b. And then the log is the exponent. So the exponent here is m plus k. So this is going to be equal to m plus k. And then the xy is what goes inside. Xy is what goes inside the logarithm. So we're back to having log base b of xy. You could also think of taking the log of both sides. That also kind of works. And so remember though what the m and the k were to start with. They were those individual logs, log of x and log of y. So what we now have is that log base b of xy is indeed equal to log base b of x plus log base b of y. So, I mean, this is kind of a tricky thing. You know, there's a lot of letters here, and it's a lot of basically just using how you can go from writing a log equation to an exponential equation, and doing that sort of a couple of times. But we have now proven, you might disagree, but we have now proven this product property, that if you have the log of a product, you can split it up into the sum of the log of each factor. And so this is all based on this right here, this idea with exponents that we already knew, that if you have the same base, you can add your exponents when you multiply. So let's look at then for the quotient property. So for the quotient property, that's where if you have division, you subtract. And so maybe I'll go over here for the quotient property. And so we're still going to have this same stuff here. We're still going to be using our m and our k as we defined them before. But now instead of starting with x times y, let's look at what we have if we do x over y. So x is b to the m, y is b to the k, and we know from working with exponents that we can simplify this by subtracting b to the m minus k. And so if we cut out the middleman, x over y is now, we can write this as b to the m minus k. And then again, rearrange using the definition of a logarithm. So we can rearrange this and write it in log form. So log base b of x over y, log base b of x over y equals the exponent m minus k. But remember, m was log base b of x and k was log base b of y. And so there we go. Log base b of x over y is equal to log base b of x minus log base b of y. Okay, so there's the quotient rule. So the only thing we haven't done then is the product, and I should say property. I learned them as product rule, quotient rule, but property's better. Otherwise you can get it mixed up with some stuff when you get to calculus. Anyway, okay, so let's look at this guy. So let me just write it again down here so that we have log base b of x to the p is equal to p times log base b of x. And let's keep our same, so this is what we're trying to prove, right? This is the product property that we're trying to prove. And so let's keep the definition that m is log base b of x and see what happens if we take x to the p, or yeah, let's see. So I should have thought about this one ahead of time. Okay, so if we rearrange this guy like we did up above, so then we would have b to the m equals x. Okay, yeah, here we go. So then if we look at just the stuff inside the log, and let's look at x to the p. So we have right here that we can write x as b to the m. So b to the m to the p. And then we know from exponents that when you have something with an exponent to another exponent, you multiply. So this is the same as b to the mp. So now if we take x to the p equals b to the mp, so just leaving out the middle bit, and rearrange this so that it's back in logarithmic form, we'll have log base b of x to the p is equal to the exponent mp. Okay, and so finally, m was log of x, or I'm sorry, log base b of x. And so mp is this log times p. Let me write the p though first, just because it's a little bit, looks a little bit nicer. So log base b of x. And that's what we were trying to prove, right? That if you have log of x to the p, that's the same as bringing that exponent out front as multiplication. So there we go. There's those three key properties for dealing with logarithms, for manipulating them, simplifying things, all that kind of stuff. Okay, so let's see, though, if we can figure out this other thing, this change of base property. So the change of base property, we're going to talk about at the kind of end of section 4.4. Where is it? Oh, yeah, here it is right here. So log base b of x Let me write it the same way I have it written over there. So it's log base b of x. You can pick any other base that you want. So let's say it's base a, and write this as log base a of x over log base a of b. And so typically the a that we're picking is either e, so we're using natural logs, or 10, so we're using common logs, and we can then use our calculator. So again, this is the change of base formula, because you're changing the base of the log. Okay, so let's do something kind of similar. Let's see. Let's let m again be the log base b of x, and rearrange it so that we write that x is b to the m power. Okay, and so let's start over here with this more complicated stuff on the right side. So log base a of x over log base a of b. So what we're going to try and do is show that this somehow will simplify to just log base b of x. Okay, so let's write x as b to the m, and then we're going to apply our properties that we've learned about. So we have log base a of b to the m power, and then over log base a of b. So we have a that power property that says we can bring m out front as multiplication. So this is the same as m times log base a of b over log base a of b. And log base a of b is something, some complicated number, but these are the same thing. We can just cancel those. And so this is equal to m. But, oh, wait, m is log base b of x. And that's what we wanted to show. So in a way, it's almost like you can sort of cancel log base a, kind of, sort of. I don't know. Forget I said that. Not really. But so the change of base formula, it actually does work. And it's based on the power property and just the definition of a logarithm.